Shall we start?
Yes,
So, see, which mode can the participants unmute and ask question? Is it like this, or they raise hands and then we ask them, or they are writing their questions on
The
chat?
participants are asking question in chat box.
Okay.
Yes, sir.
So, anybody have any questions so far?
Good afternoon, sir. Sir, can you please share the link of the Google Drive once again for the Python programming files?
Okay. I think I've done this. Okay, so let's continue with the second part of my talk, my discussion on Python programming. Let's see if, So I'll start with some discussion and then we will again move to our Colab file where you can see the live demo of the code also. And since I have shared that code with you, so best is like you do some trial and error, run that code and make some changes. Then it will definitely make a lot of sense. I hope my slides are visible.
Yes, sir.
Okay, good, great. Let me put on my video also so that people should not feel like very monotonous. Okay. So what we have seen so far in the first session is about like discussion on data types, integer, floating point number, I mean real numbers, Boolean, then string. That strings are a very fundamental data type and very useful data type because a lot of applications require string manipulation. The strings comes very handy. So these data types we have seen. And now we are going to discuss about some advanced data type, which include list, tuple, and then dictionary, set. And probably we'll skip our discussion on binary data type because not really for most of the application we don't use them. So for system related applications, they might be useful, but we'll keep our focus list, tuple, dictionary, and set, which are fundamentally like used in data science applications. So, and they are very useful data types. So that we will discuss, and then we will take some look on some data science related packages, right? Modules and packages where we use NumPy, Pandas, and Matplotlib. These are the very used libraries, very useful libraries for performing data science operations. And you will be also going through some machine learning steps. So scikit-learn is another library where we can import the functions for machine learning and can use directly from in our code. Those kind of things we will discuss. though I will not discuss scikit-learn, somebody else should discuss it. But we will take a look on NumPy, pandas, and matplotlib for the basic data science operations and visualization. Okay. So strings we have discussed a lot. I hope that you are now comfortable with the string. Right, it's a class of this data types like str string. They represent sequence of character, right? And these kind of things are like single quote or double quote and backslash we can use to continue them, the next lines and so. If you talk about like string operations, then till now we have used the strings for display and for formatting purposes and all that, displaying the results and all. But can we deal with strings, right? Can we process strings further, right? Can we do indexing and slicing, right, to obtain some substring? So can we extract some part of strings from that main string and can create another string? So that's like slicing. So indexing is like referring to a particular alphabet, particular letter in that string. So can we do those kind of operations? And the answer is yes, we can perform indexing, that we can refer to some particular character in that string, or can also refer to subset of character in that string. So that's what the indexing and slicing about. And very interestingly, this indexing and slicing, as we'll discuss further on other advanced data types, for example, list, tuples or sets or dictionary, you'll find that these operations are also applicable. That we can perform indexing or slicing for those data. So this typically I can call them as sequential data type, sequential collection type of data type. In some sense, there are elements which are stored in those collection. So string is also in some sense is a collection of characters, but the point is string is not mutable. So you cannot modify a string. So you can perform some operation on that string and get a new string, but you cannot change the original string. That's the mutability of string data type, right? And then there are many functions that will come with not only these strings, but all those data types which we will discuss, whether they are list or tuples or dictionary. So they come with a lot of like handful of functions which can further reduce our task of writing code, so that we can straightforwardly use these functions to, for example, this capitalize will convert the first letter to uppercase. So you pass a string, and whatever uppercase letter is, like it will be converted into you can change the case from lowercase to uppercase and vice versa, right? You can encode in some encoding scheme. You can index within the to get a particular character from the string, right? You can join the strings. You can figure out that if there are like a number of functions, like if the string are lowercase, then you can perform certain Boolean operations also. So here there's a like list of, and this list is available on internet. I mean, just type the string functions, and you'll find there are lots of functions which you can use directly by just putting a dot and calling this function with the string variable and get those kind of work done, right? And then we will take a look on sequences and collections. Sequences, string is also a sequence in that sense. So, but then here we will be talking some advanced data type. String we consider as basic data type, though string is very useful. But then, yes, there are even further involved data types like list and so there's 4 data types that we will discuss today. There's a list, which is a collection, which is ordered. So collection of elements, collection of objects in that sense. And as you know that I said, Python is an object-oriented. So even the integer or string, these are all objects. So collection of objects which is ordered and changeable. So when we say that ordered and changeable, that means you can change a particular element of the list. You can modify the existing list, right? It can have duplicates, whereas this tuple will be a collection which is ordered but unchangeable. So tuples are basically called non-mutable, unmutable. I mean, you cannot change the element of the tuple, right? So it's a kind of constant list. But it can allow duplicate members. So list can allow, tuple can allow, but set do not allow duplicate member. So it is not ordered as well. It is not ordered. Since it is not ordered, indexing will be difficult because when the elements are not in some order, how do you figure out that this is first element or second element? So it is unindexed also. Like so, there are obviously there are functions to access the element from the set and storing the element, retrieving them, modifying them, the set and all that. It's a changeable that you can make changes. So it's mutable kind of like can change the element, whereas tuple is not mutable. And dictionary is a collection. Basically, it's a key value pair. So you'll find that when we want to store like name, and what name is like a particular name. Name is Atul Gupta, age is like 52. So you see, we typically in databases and data storage where we require with respect to some metadata, the data to be stored, the dictionary are a candidate to deal with storing those data and manipulating those data. Here, we don't have duplicate members. So obviously the reason is like keys, because they are key value pair. So since keys are unique, so therefore for one key, you will have one corresponding value. So there are no duplicates which will be stored in that sequence. First, take a look on list. So I think let's directly go to the code rather than slides. That will make us things more clear and understandable. So what I do is like I stop this and I share the code file. And what I do is like okay. So let's start our discussion on list, right? So list, tuples, dictionary, and sets. It's in the first collab file itself. So we haven't moved to second file, though it may look like that it's a second session. The file will be second file, but we haven't reached there. Slightly moving, slightly slower. Don't worry about this. You open the first file, first collab file, and come to this section, which is like built-in collection type. This is built-in collection means you don't have to import anything from outside. It is default available in Python. List, tuple, dictionary, and sets. And as we know that their properties like lists are mutable, tuples are not, dictionary is also not, and sets are mutable. And then they have their own other properties also. So you know that when you need a particular type of collection, you will be using them. And the most general form of collection is list, which is like the most general, where you can change the elements and you can perform a lot of different kind of operations. And it's a fairly general kind of data structure. So for example, here this is a list. Here you can see like, and this list has 5 elements. So you can see the first element is a string, second one is integer, third one is a real number, there's floating point number, the fourth one is again a string, and fifth one is a real number, right? And there is another list which is tiny list, as the name suggests. See, when you write your program, you are highly encouraged to use sensible names, so that it makes sense that why we have used this particular variable to store. So that improves the readability of your program, and this is one of the best practices that use your name for the identifiers sensibly. give them name sensibly, the function names also very sensibly, so that one can quickly understand that what this function does or what this variable might be doing, right? So those kind of things. Now you can see we are performing operation that is like this is a kind of indexing operation where I have passed this this index -2. This is interesting. This is the index can be minus also, and then this is a slicing operation where I'm giving a range of elements in that list. So we would like to print some elements from element number 1 to number less than 3. So 3 is not included. You will find that whenever we specify some kind of range, so the terminating element is not included. That's you should always be careful for this convention. This is Python notation or convention, and we should be aware of that, right? And then we have, this is also a range 2 column, so it start with the second element, second index element, right? Not second number of element. We'll come to that. And on the right side, there is nothing. That means all elements after the second index element. And then we are performing something called, applying an operation here, multiplication operator. So think about it. You multiplying a list by 2. What does it mean? And then you are adding 2 lists. This plus we have used for integer, we have used for strings, and now we are using we are using it for list also. So think about it. How sensibly this operator, same operator, behaves and helps us to perform internet task, right? Okay, so let me run this. So this is obvious that when we print list, all this list, mind you, the list is whenever we use this like square bracket, this is a representation that this is a list. If we use small braces, then that is a representation for tuple, and curly braces, then it's a dictionary, right? So those are the different kind of representation that allows you to understand that what variable, what data type you are using here, and accordingly, that variable to which it is referring to, right, the reference variable, that will be of that type, right? So you can also always check the type of, whenever you have some confusion that what the type of this variable is, just simply take a print command and check the type by displaying it, and you will see the type of that variable, right? So you can see like the first print statement is this list, and then we have this -2. Now this is interesting. When I pass -2, so this indexing idea in the list is like this, right? You got, this is the so there is like forward indexing as well as backward indexing. So it works both ways. So it start with 0 if we moving forward, 0, and this is 1 index, this is 2 index, this is 3 index, and this is 4 index, right? And if you move backwards, so if you start from here, this is -1, and this is -2, this is -3, this is -4, and this is -5. It's just like a Python convention, but then you need to remember this. So when you say list -2, right, index at -2, -2 is this. So corresponding element is John. So that's why you get this John printed here. This is 1, 2, 3. 1 is this 786. This is included, and 3 is not included. 3 is this, but this is not included. This, and I see this whenever there is a column B, so the A is included, right? B is not included. So just before B, this is again convention, and this is how Python range work. We need to be careful while we deal with this. So 1:3, like it start with 1, will not go to 3, but just before 3, which is 2. So it will be like you will have 786 and 2.2, 2.23, right? And similarly from 2 second index element 2.23 to rest of the element, that is this. So you can see like we are slicing this list with this range operator, right? And indexing also by giving the index one single. And then when you multiply a list by 2, I mean, sounds like maybe initially ridiculous, but then yes, what this operation is, it's a concatenation. That means this 2 list, the same list is concatenated with itself, and you're going to get this kind of things. So 2 element in that list, tiny list, repeated twice, and that's what has happened when we have performed this, right? Please don't note that there's like none of the is causing the original list to change, right? All these are performing certain operation and showing the resulting list. If you want to store the resulting list, you need to have a assignment operator to work and store that. We have got some more example. I hope that you can, this like, for example, delete operation, and it is deleting the second element. So again, it's the index. As we know that indexing is possible here in the list. So they'll list 1 and this like second element, that means this like second element is not chemistry, but 9, because this, right, this is the 0th element. This is the first element and this is the second element. So when we say 2, it's like the second indexed element, which is like 9 to 10. So what you're going to do after you delete it, you will get this is not up here. Okay. You can create with this range function a list. I mean, this is a constructor which create a list from now. And then you see that here in this range function, we are passing just 1 parameter. We have passed 3 parameter earlier. So depending upon, I mean, what we intend, if we pass for 1 parameter, I mean, this is obvious that the increment is 1. The starting 1 is from 0, and it goes to that just 1 less than this number, which is like, because this is exclusive number, kind of when we say range 5. So range 5 is 0 to 5, not 5 is not included, so it will result to 0 to 4, right? And there is some more example code that where you can play around with this list which you have created and replace it with. So this is all mutability of list, and you can make changes in the list, and the original list can also be changed, right? That's possible, right? Here you see in this example, I got one list as num list from 0 to 4, 5 elements, and then I've got another list which is empty. This is the like syntax for showing that this list is initially empty. And what I'm going to do, I'm going to insert this. So I'm using some operation. Now here you can see, just like we have seen operations with string, there are many operations, I mean around 25, 30 operations which are defined for list also. So this one is append operation, right? Where you can append in a list another list. That's what is happening, right? So what is happening here in this for loop? It's not the list, but the element which is getting appended, right? So for x in num list, this is a for loop. What it is doing, right? For x, a variable, any variable, just which is like looping variable in, this is a keyword, in num list. Num list is a list. So this is going to iterate over all those elements one by one. Initially, x will be 0, then x is equal to 1. In the next loop, x is equal to 2 and 3, and so on and so forth. So for this is a for loop, and when it go inside, for the first time, x will be 0, and then the next time is 1, 2. And this is the only statement within the for loop. You can see that this is the gap, this is the alignment, and that's why this suggests that this statement is inside the for loop, and this statement is outside the for loop. So this is important to when you read the code It will be obvious, but then we need to initially little bit careful to understand that what is the body of this for loop, what code is inside and what is outside, so that may reduce some trouble initially. So you see what is happening is like we are going inside of this for loop. This x is initially 0, so 0 square 2 is 0, right? So first element in this list, square list, is which is appended by this argument. So this is the value of the element. So this is evaluated. This is the expression, right? So it will be evaluated before it is getting appended. So first it will be evaluated. X is 0, right? 0 to the power 2 is 0. That is getting appended. So first element that is going to appended in the square list is 0. Mind you, this append function is going to append at the last. So whatever the list is where we are appending, any element we are appending is going to append at the end of that list, right? So that is going to be last element and so on and so forth, right? So this will be continuously will happen uh, for 5 times because there are 5 elements, and it's saying that this x will iterate over all the elements one by one. So x is in its 0, 1, 2, 3, 4. Take all the values one by one. So 5 elements will be appended. And not just 5 elements, they're square. So initially the x is 0, this is like 0. 1 is square is 1, 2 square is 4, and 3 square is 9, and 4 square is 16. So you'll see that at the end of this for loop, we will get this square list as this, which is square bracket and 5 elements, right? Now, if you want to print it, you're going to get same results. Right? Sorry. So if you print it, you're going to get the result as 0, 1, 4, 9, 16. So this is a simple code, small code, but it says that like you can manipulate list, you can use more list to perform, to store the elements temporarily or whatever like purpose that you would like to do. So whenever we need to solve a problem, like we need to understand that what data type we need and how you're going to use stored data of your program, the input data, the data which will be generated during the processing also, and maybe you would like to communicate or present it as an output or store in the file. So all this need to be yeah, understood and planned for, and therefore that is how you will decide what data type, what kind of data type that you will be needing, what variables, data variables you are going to use in your program, and how you're going to use them. This is all about like you will be designing accordingly. Here you can see in the next example, we have got 2 lists, A1 and A2, and we are performing this addition of 2 lists. Again, since A1 and A2 both are of type list, and addition of this list is basically a concatenation operation, so this is possible. So basically, there's no issue. We will get a list as an output where we'll have mind you, the original lists are not updated, but the result is nothing but. So what I can do is like I can add them and I can store them as A3. So I can. So this is what I can do. I can say I3 equal to A1 plus A2, right? So I can do this also, right? So I'm printing only this statement, so that's why this is coming, but I can also print, right, A3. And you will see the same results. So basically, what is happening here is like, you know, that this plus operation. So this becomes an expression. Whenever there is an expression anywhere, right? This is one thing which will be common across. Anywhere there is an expression that is written, you're not passing like a single value, but rather than an expression, that will be evaluated, and then the further actions will be performed. Okay. So when we have given two lists, when with the operation plus, let's say you want to perform element-wise operation. You want to actually consider these two are vectors, one-dimensional matrix, and you want to add these two matrices, so that the result will be 1 plus 2 is 3, 2 plus 4 is 6, 3 plus 5 is 8, and so on and so forth. So you will be having. So that you cannot do with the list, right? That's the problem. I mean, you need to either take out the element and perform some mathematical operation and then store it again as a list. So that may be a little more involved. But then we'll see that there is a package called NumPy, which will make your job very simple. So all those matrix manipulation, matrix operations, where we can perform those just using one single command, and all these things, all those things can be taken care of. So, but that is a library, separate library, not inbuilt in. So there you will understand that how to use library. And once you learn or you are comfortable of using libraries, and world is yours, because it's for any application, it's actually what we do is like we make use of libraries where the functions are already known. What we need to know is like what function we need to use, and those functions will take some input. So what inputs we need to provide. So our task will be to compute these inputs, which we need to provide them to calculate, to compute, and then call that function, pass those as argument in that function, get the work done by just calling that function. And it will return some results that has to be captured correctly, depending upon what kind of results it is going to provide you. Once you can do it, I mean, you're done. So this is something which is very, very straightforward. And this is something very powerful that is like a feature of Python, where we, and other language also like, but then Python has got very powerful and very versatile kind of libraries where people like us don't have to write much code, and we can actually do a lot of sophisticated kind of operations or projects we can create, and we can come up with that project getting the code is generated, and you are getting some outcome from this. Now we have discussed list. Now this is tuple, right? As you know, how do we decide tuple? Not with this name as tuple. This is the name given by us, and we can give list also, list one. So that's not an issue. So why it is tuple? Because it is the elements are enclosed in a small process. That's why it's a tuple, right? So you can actually see the type of this tuple also. You can write down a statement by checking the type of this variable, and it will tell you that it's a tuple, right? And what is the difference between list and tuple? The tuples are immutable. So if you want to, you can access that, you can index that, and you can slice that also. But then the original tuple is not going to change. You can slice and store it in some other tuple or some other way. Like there are ways of converting elements from list to tuple or tuple to list. So those kind of, like, sometimes they become useful. Now here you can see like what we are trying to do. We're trying to assign the first index element, which is like this is the first index element as EM090. And this it will not allow, because what we are trying to do, we are trying to modify the content of the tuple, which is not permissible. Whereas if it would have been a list, we could have modified a particular element in that list. If it would have been a string, no, again, it will not allow, because string is also unmutable. They are not mutable. They cannot, their elements cannot be changed. Okay. You can delete tuple also, the whole tuple, but then yes. Right. And then we have dictionary. Dictionaries are nothing but, as I said, the key value pair. So here the key is, for example, string. These are string type keys. Like this is one string name. Name is Sarah. The age is 7. Class is first. Like, so we have got one record. So basically, string in some sense you can think of like maintaining records, right? And it's very close to like the idea of databases, like how do you store your data? So it's like key value pair, right? The record name is Zara, age is 7, class is first. You can add more, you can have more data that you can store in the string in the dictionary, and you can access that data with this key key. Right. So, for example, for this dictionary, that is the data reference variable for which is storing this dictionary. If we like index that through this key value, name, for example, then what we are going to do, we are going to get the name from this dictionary. So when you want to get this name, what is the name? So this will result in Jara. What is the age? So that will give you the MS or the age as 7. So this is how, like, you can see, like, it's a key value, but this is the key. And what is the value store will be accessed through this indexing mechanism. Here you can see, like, how this has been indexed is by giving the value of the key and the corresponding value that is stored and the key is extracted. Here you can see I can update also this here. For example, currently we have the age stored as 7. I can change that with 8. So that's immutable. So dictionary elements, I mean, the values that they can particular like values can, but then the left hand side, the keys cannot be changed, right? Keys once decided, they will remain the same, right? You can change the values, right? And you can add more keys, just like this. What is the school? DPS school. So currently in this example, you can see we have got 2 key value pair, no, 3 rather. So just like we have name, then we have age, and then class. And now we are inserting here, school also. So school is also a key here now. And we are giving some value, particular value. So this is the key, and this is the value DPS school. So now when you do this, automatically that particular entry, which is like, now there will be one more entry, which is like school and the name of the school DPS, that will be inserted in that dictionary. Then we have set up data types, set, though they also use this curly braces, but mind you, if you use this empty curly braces, that doesn't mean this is an empty set. This is an empty dictionary, right? Though set representation will come with a curly braces, which will share the visualization with the dictionary. But please note that if you try to initialize a set by this, by having an empty set, just like empty list, we have empty square bracket. Here, if you do that, then it will initialize a dictionary rather than a set. But then there is a way, there are like constructors or creation of data. Let's say you want to create a set from a list. So that you can do actually by just like this. You can see we are creating a set by passing a list, right? So this is like any side list, right? So what we are doing, we are creating a set. So empty set will be of type set rather than a list, and this is the list that we have passed. So actually there is a way to and many ways to actually to convert data stored in one format to other format whenever it is needed. I mean, sometimes we need to convert list into set or set into list, and then processing those lists and then convert back to set. I mean, those kind of things happen, and there are operations which are available. There are functions which can allow you to do those kind of things. So as you know, set are basically collections which don't include duplicates. So right. So if you create sets with multiple duplicates. And so list may contain duplicates, and then you want to reduce these duplicates. Just convert that into a set, and you'll get a list with without duplicate, and convert back it to the list. So let's say you have a list of duplicate elements. You want to remove all those duplicate elements. A very simple idea is convert into set and back convert into list, and that will remove all the duplicates. So like very simple ideas will make your task very easier. I'll skip this exception part, though exceptions are good, but then don't worry about exceptions too much unless you want to learn the language in more detail. Generally, the code that we are going to use, we take from some place, and if there are exceptions they have defined, just leave those exceptions there only. Exceptions are basically dealing with runtime errors, right? So, for example, if you divide 40, I mean, if any of your statement, if you have, let's say, something called A divide B, right? And a B, somehow B becomes 0, right? So that's the problem, right? Something divided by 0, so that's an error, right? Undefined kind of, like, and this value cannot be used anymore in the program. So what the runtime system does, like when it recognizes that the denominator is 0, it raises an exception. Exception is nothing but an event, a flag, which is raised for the environment that something bad has happened. So if your program is can take care of, like, can catch those exceptions, right? Can read those exceptions, then it will not crash. But if your program, your code is not handling those exceptions, those events which has been complained by the system, and if you don't have code to handle those exceptions, then those exceptions will make your program crash because the exceptions were unhandled. So exceptions are important things, right? It's not that if there are exceptions, then it will cause the program to crash, and therefore they are bad. No, they are not bad. The bad thing is that something wrong happened and you're not able to take care of, and then your program crashes, right? But then since it raises an exception, so you can have an exception handling mechanism in place where in program itself you can handle those exceptions, right? So handle those exception means your code will take care of that. If I run this, then it will crash. It will crash means it will generate an error and your program will crash. But if I use this code, same code, and then let's take the simple one. So this is the same code, but now we have this try and catch, which is except block. Here it is except rather than catch, which is in Java, for example, we use the catch as the keyword. Here this is except, and so having this is accepting this exception, and then this is the block. This is the code block for this except part. So what it is doing, this part of the code will raise an exception. So if it is ignored, that means your code is going to blow up, I mean, break and crash. But if I use this code, then it will not break. It will raise an exception here, and the exception will come through this except mechanism here on this part of the code, where we have some exception handling code written, and that will run. And after that, whatever other code which is there, that will run. So you don't have to whatever code. So your program is not going to crash, right? So that means that exception is handled successfully. I mean, your program hasn't crashed. So that's the purpose of like exception handling. The exceptions can raise here also, and exception can raise here also, right? In the exception handling, because that is again some code. So you see, there can be like nested of exception handling code, because some code is raising exceptions, maybe multiple type of exceptions. So we can have code for handling those exceptions, and within that exception handling code, we can have further exception can come. So it's an exception handling mechanism, which is very like useful and very will make your code very robust, so that it is not going to crash more often, right? So it's a good quality of code. That is, it's one of the one of the best practices that your code should have proper exception handling, right? Otherwise, what may happen that sometime due to some input events or some situation, there are exceptions which are generated by the system, uh, but not handled, and therefore definitely this is sure it will cause your program to terminate crash, right? Just like you might be using apps and there are some apps which are getting crashed. I can tell you like most of the time this cause is nothing but some part of the code is raising some exception, it is not being handled, and program is simply hang or crash. Those kind of things happen. So it is very useful, but I'll not give further attention to this. Right. Another important concept of programming is functions, right? This is very important idea which will make your program like more modular, manageable. So it's not like when we write program, we write 10 lines of code, 20 lines of code, 100 lines of code. When we real programs are thousands or 10,000 or not just millions lines of code. So when we have the code of like million size lines of code, we cannot write all that code in one file or two files or things. So what we do is like we try to modularize those code. We figure out that what are the high level function, and we put all that relevant code to that function. So, and there are some low level functions, also small functions, some bigger functions calling functions further. It's a nice functional hierarchy where these functions are very helpful, very critical to to help organizing this code, right? Large code. And we cannot do away without the help of this function. So functions are very useful. And it's a kind of like reusable piece of code. You write a function in one place and you use multiple places, right? So code is written in one place, just like even like the libraries that we have discussed, that you can import libraries and use those functions. So those functions, again, their functions in those libraries are nothing but this reusable piece of code, which you simply call, name that function in a code and give them correct set of argument values, and you can that will run and will return you the results, whatever results that you were expecting. So this is wonderful idea that writing code in terms of functions. So for example, here I'm writing a function, calculate sum, and what it does, this is the name of function, def stand for definition of this function. So I'm defining, it's a keyword. And what it does, it's a very small, simple function. It takes two values, A and B. And what it returns their sum. So basically, very elementary example, but then it should serve the purpose what the function is for. So what it does is calculate the sum. So I pass any two number, right? Let's say if I want to add 2 and 3, the next time I would like to add 10 and 15, or maybe 1,000 and 3,000. So maybe every time I'm giving different numbers. So I cannot hard code these numbers and do the hard coded way of addition. What I can do? I can write a function because it is doing same thing. Only thing is like the argument is different. So this function will take different argument, will compute the relevant information, and then return it. And that's what this function is doing. So this is the functional code. This is not the part of main code. It will only execute when we will execute the main code. So main code is, leave aside all function code. The remaining code is main code. So for example, this is a part of main code. So what it does, it is printing. Now, interestingly, we have used like some functions already. Now this is the user defined, our defined function, right? We have defined it. Calculate sum. This is our function. इससे पहले function जो use किए हैं, they are all like available somewhere else, right? They are library function. A print function itself is a function which we are using it, and we don't know what is the code of this print. So, but then we know now what is the code of calculate sum function. That is this is the code, right? And what it does, it takes two parameters. So we are passing 234 and 56. Now what is happening? When this function will be called, right? What will happen? The parameter will be mapped. That means 234 will be like mapped to A, 56 will be mapped to B. So obviously these parameters should map whenever we are using a function. We should be passing those parameters which are required. And then what it does, when A equal to 234 and B equal to 56, it will simply add these two and return the value. And when we call this function, so ultimately what will happen, this function will be called and it will return. It will return means whatever return value is going to be within this print function, and this is going to be printed. So that's very straightforward. Like we have used this function and used inside this print statement. So a function within function, just think about this is an example of where functions can become parameter to other functions. So for example, print is a function. It takes, I mean, what we have seen so far is some simple values, right? Some strings or maybe 2-3 values and print, and I can do a formatted printing also. So all these things are fine, but then here you see that I'm passing a function within that function, print function. So this is typical of like this coding. When your your coding skill will improve, when you start doing bigger coding, you will see that you will be making use of this kind of thing that you're passing functions in another function, right? So that to get the work done very quickly rather than using variables and calling them separately and then using this variable code. So it's all about like how you optimize your code, how do you reduce the size of the code, improve the readability, understandability, and that makes a lot of sense for writing better code. Here you see I'm not passing the integer value, but then this is a floating point number, and this time and the next time I'm passing is a string arguments. So just think about it. This is the same function. So at one time it takes two integer, next time it takes two floating point number, and third time it takes string values, and it doesn't misbehave. I mean, it does what it's supposed to do, right? Why it does so? Because we know that the computation performed within the function is a plus b, and we know that plus is defined for integer, plus is defined for floating point numbers, and also defined for strings. So whatever it returns, we can get this printed and without any complaint. There are some more examples of this function, so I think you can go through it. And a function can call itself. So for example, this function 1, when we are defining, we are calling function 1 itself. So this function calling itself, it's a recursive definition, recursive call, and which can be complicated at times if you don't have way of terminating. So what is happening if I call this function 1? So when I call, this is the main statement, that is the main program statement. This is the function body, and this is like your main code. So this is like just one line code, and what it does, it calls this function. So when this function is called, which in turn will call this function, which in turn will call again that function. So you see that this we are getting into some kind of infinite loop. Thanks to like this Colab environment, what it does, it identify that we have gone to a infinite loop, and it will terminate after some number of iteration and figuring out that this is infinite loop. But for systems where this kind of obviously this is terminated, so it's a kind of crash. So obviously you don't want your program to crash. So we need to be making sure that our program is not in infinite loop. So wherever there are chances that a program can go infinite loop, we should write appropriate code to ensure that it is not getting into that kind of loop. Because if once it goes to infinite loop, obviously it will crash. There's no other way. Okay. And this is the recursive error message that will suggest that this function got crashed because like it's kind of infinite loop. Then we have some more example, like you can see like here. So you see our main code, which otherwise that can be this code, but we have defined that as a separate code and given in some name. So that's the practice of writing code. That if some part of the code is taking some value as input and performing and providing some output, we can wrap up that code as a function, giving by name, defining them and giving a name, and all that input that it takes defining as a parameter, and whatever it returns as a return, and then the main code will just one liner, right? Because you call this with this argument, and this code control will get inside this function. There is loop, it will go inside that loop, continue. But your main program is just like one line statement. Just think about it. I mean, this is a way of like organizing your code, like making your main code simple and writing your most of the functionality in terms of functions or smaller functions, calling them some other functions also taking help of. So it's like in that sense, we are composing your code, building on this code small function, and within that outer that, like we have got larger functions, maybe calling multiple functions to get the work done, and then we have even higher level of hierarchy of function, and finally your main program, which is one single big function. So that in that sense, this is like very nice way of organizing your code. Reading that code, making changes also will be straightforward. This is another example where the interesting example, those who are familiar with programming, they may know that switch is a statement which is there in C language or Java language, but the switch statement is not there in Python. But if somebody asks like how to implement switch in Python, so again, you see, here we have used a dictionary, right? So switcher, this is nothing but a dictionary data where we have this key value pair. So like 7 key values, 0 to 6, and if it is 0, and what it does is like whenever you want, like what is week 6, so it will week 6 is like this function, this week function. So 6 is the argument, it will go here, and you know like what we are getting here from this data. So this is the function get I. So the get 6, right? So if 6 is available, I mean all these values are available, then it will return that corresponding value. That is the, for example, if I run this, it will return me Saturday. But if it is not there, let's say if I pass 7, just see the how simple and elegant idea this is. Then it will give me another message that it's not a valid day. Obviously, 0 to 6 with 7 days has been already taken care of. So this 7, so there are 7 days, but we start counting from 1. Here it is, we are doing it from 0. So 6th is the Saturday. 7th is outside of the number of days, weekdays. So you see, if I is valid, then we get the valid value corresponding to that I, which is the index, which is the key. But if it is not valid, then we are going to get this message printed. So you see, it takes care of all those scenarios where it is successful and it is not successful. You don't have to like write all that complicated error handling code. So let's move to like quickly to second part of programming exercises, where we'll discuss about the important packages, right, which are very useful, which will be useful, and probably you will be using it in your data science exercises or projects or whatever. So I close this and I open the second Any questions so far? People are asking for recording of all sessions. That the organizer has to look after. If you have any question regarding the Python part, I mean, that has been simple. I understand, and I hope that you must be following it. But anyway, if you have any question, then yeah, no issue. Okay, no question. That's great. Very clear. Thank you very much. If you are going through, I mean, this is a simple idea, and I tell you, like Python is so simple. It's not that I am explaining it as simple. Python is really simple. Only thing is you need to put a couple of days, 3 days, and you can be writing some good size program, right? There are lots of code which is available on internet for all kind of purposes. So I mean, probably I understand that nowadays we are familiar, we are good at asking Google how to do this, how we do this in Python, those kind of things. And I can tell you, just type that and you will get a number of results, and you can whatever you required, you ask for, you will get that kind of, right? You know that we are getting almost, I mean, whosoever watching TV, you know that Google is giving that advertisement, ask Google. Ask anything from Google. So ask sensible thing, and most likely you'll get those kind of answers. So even if you're getting some kind of error, even if you're getting some kind of like you puzzle somewhere that why it is not happening this or why this kind of things are happening, just type that part in Google and you probably can get the answer instantaneously. So such a simple idea of learning programming that Python together with the Google support has made this like programming is no more a complicated or a difficult job. Programming is so straightforward nowadays. Anybody can program, and that's why people are claiming anybody can program. You don't have to come from computer science background or any allied background. You can be from any background, can write programs. And because of the availability of this library, huge library, you can quickly write or use these programs to solve some good problems. So so there's no point nowadays. I understand. I understand that if somebody think about that, programming probably is not their cup of tea. Just a matter of few days, maximum like 7 days, and you will be comfortable. Just think about it, where you would like to focus your effort. I mean, what kind of problem that you're trying to solve. If it is a web application, then you don't have to read about NumPy, Pandas, and Matplotlib. But if it is data science or machine learning stuff, then you have to know about these libraries, their uses. And there are a lot of code already available on internet, which has solved some problems, example problems, or more complicated problems also. Even the researchers are nowadays are showing their code. So it's becoming so obvious and straightforward that you can download their code, you can run their code, the data set is also available, and then do some troubleshooting that why results are coming this way, or can you, or would you like to make some changes here that will change the policy or algorithm, and you may get better results. People are doing it already. So it's like Python for all now. Right. So 3 libraries we'll discuss today. Like quickly, I'll go through it in maybe 15-20 minutes time. I will try to do this. First is NumPy. This is like numerical Python, like pandas. So these pandas are typically for reading data from file like Excel, CSV files, where we typically store our data. And Matplotlib is the library for plotting your data, right? So various kind of plots, very kind of visualization that you can give. So these are wonderful help, wonderful like reusable piece of code, which is included in those libraries. What is a library? Library is nothing but a collection of function files, and each function files are nothing but called modules. So these are nothing but a collection of modules. Each module contains a number of functions, which is like doing some useful stuff. And what we are doing is like we want to use those functions just like we are using this print function or any other like typecasting function. So similarly, we want to use those functions to get that work quickly done. And that's the idea that comes when we use this library. Right. So here in this example, we start with that scenario where you have seen that we have initialized two lists. We try to add these two lists. So what is happening that these two lists are getting concatenated? Because this data type is of list, right? That's kind of like deal with strings rather than they can perform bitwise arithmetic operation, right? And that's what if you want, like in the numerical processing, the vector processing or matrix processing, matrix multiplication, addition, taking inverse, we need those kind of like operations to perform on the data that we collected. So that is how we are going to do that. Right. So here, how we do that? So that is the library NumPy, right? So first library that we'll discuss is NumPy. And what is the statement that I'm using for importing that library? NumPy is the name of the library, which is also available for most of the Python installation. And in Golab, I mean, there are some libraries already given to you, like users, so you don't have to install this library. But sometimes some library is not installed, so you have to download those library. There are some couple of lines of code that you can write, and that will be installed to your platform or your environment, and you can directly use. Here, the NumPy is already available, but just we need to indicate, signal that we have intent to use NumPy. And here, I am putting a kind of alias, that is I will be referring this NumPy as NP. I mean, NumPy is smaller name, and NP is further smaller, that's fine. But we can have a big size name for some of the libraries, and that we can create an alias. An alias nothing but giving a second name to that library or that module file, so that you can use that. So here, when I say NP now, so I'll be using this NP term in my code later on. I'm not using NumPy because NumPy is referred as NP. So for rest of my code is going to use this NP as the alias, as the second name for NumPy. Now I am using the array. Now again, you can see this is a very sensible way of naming the variable. It's a variable, but what I'm saying NP underscore array one. That means this is the first array, which is a NumPy array. So NumPy array are the basically numerical array for numerical processing, right? So there we can perform now numerical processing, right? So here you can see what I'm doing is like I'm using this NumPy array to create a NumPy array and pass. So I'm using this constructor, right? So basically an object-oriented concept idea that to create objects of some kind of classes. So here the class is just like we have discussed integer, string, list, and tuple, and all that. So here it is ND array, that is the class, and this function is a constructor which creates an object of NumPy array. So NP dot array, that's a constructor, and it takes here we are passing a list, simple list, right? You know, square bracket. Anything is in a square bracket, the default is list. So it takes the list as an argument and convert that list as a NumPy array. Now you can see there what is the type of this that array now. So first time when you will run, probably it may take a couple of seconds to get it going because we are importing this. So import may take some time, and many times we may import more than one kind of packages or module. So that may take a little more time, but then after that it will be okay. So, and since everything is running on cloud, so it may understand that if you do it on your system, it may take less time. Same code will run very quickly then it takes some time. So here you can see like the class is numpy.ndArray. So ndArray is like the type which is like defined in NumPy package. So this is the type of this class. So this class is not by default a data type in the default Python. It's a separate library, and therefore we have defined some data types in those library, and this is one of the like ND-array. So it's not a list. I can actually, you can do some changes here. You can use a list. You can check their data type as list. It will be class as list, and you can pass that list here by its name, and then create an ND array, and then we will check the type of this ND array. You will find that this is ND array, right? Not the list. So you can do these kind of small things to enhance your understanding that what is going on. We are using list, and then we are creating ND array, numpy array from the list, right? So lists are typically not manipulatable from the mathematical point of view, but then it is ND array I can do. So let's say I'm created two ND array. Now it's straightforward, and I'm now adding these two. Just see that when I'm adding this, you see that now I'm not getting a concatenation here, but rather than I'm getting a point element-wise addition, right? Similarly, here element-wise multiplication also. So you can see here this third print statement is nothing but multiplying. So it's not concatenating B2 as a simple list and repeating 3 times, but rather than multiplying 3 with every element. So here we started our like numerical processing where so this A2 is not. See, we got a problem here. Problem is that we have not initialized. So we have not run this, right? So that A2 was not available, and then we are performing operation on A2. So there is a dependency between this cell and the previous cell. Now if I run, I'm not going to get an error. So here you can see, I mean, the way we can perform this mathematical operation on this vector, and eventually then we can have matrices just like here. This was single dimensional. We can have 2 dimensions where we specify the dimension also, and initializing this MP, this 2-dimensional array of which will be of type integer and which will be populated with ones. So this is a function which is already there, np.ones. It takes like the size of the array, can change the size, and the type of the data that with which it is to be initialized, right? So it will be initialized with you can initialize with floating point number also. That is so you got a matrix created. So you can actually create a matrix of zeros, ones, or any other numbers, or random number also, right? You can create this matrix for random number, right? So np.random, that random function. So this function within this module random, right? And it's the size of like 10 cross 2, so 10 rows and 2 columns. So you can see like this has generated random numbers of size 10 cross 2. So we can actually generate any like for any matrix, any size matrix, we can generate random number, and you will find that these random number generation are typically that we use in machine learning algorithm where we generate those random number initially and then manipulate these numbers, update them. Like these becomes the model parameters. So these are the useful statements and aspect of like NumPy array that it allows you to deal with directly like creating matrices, random matrices, multiplying them, and all that kind of things. So here, all these examples are nothing but, so for example, here this add function. So you are adding in this NP array, you are adding this too. So there's like not just the plus operation, but here you see I'm using this add function np.add. The add function takes an NP array, which we have already defined, and addition value. So this 2 is like scalar value, right? So what it is going to do is going to add this 2 value to each element of this NP array. And so it's like again the element-wise operation that is getting performed. Now here you can see like we got 2 matrices. Now you can see like we have created these two matrices from scratch by declaring this two-dimensional list. These are two-dimensional list. We create a two-dimensional array from two-dimensional NP array from these two-dimensional lists. These are two lists, and then I can perform this multiplication. When I perform this, it's nothing but this 2 by 2 matrix. The two matrix of 2 by 2 multiply, giving me the third matrix of 2 by 2. Right? That's how this. This is just a simple example, but it tells you like this. I mean, you can multiply matrices, any sizes. I mean, obviously, this when you multiply, you need to know that what matrix can be multiplied. You know, the order are important. Their cardinality in that sequence are important. Some matrix, some ordering may not allow the matrix multiplication, but some other may allow. So those kind of things you probably aware of. So you can use some functions also. You see, I have used the simple multiplication symbol, which is overloaded. So how it multiplying two matrix A and B. Just think about it. I mean, this is simple multiplication operation, but now it knows that these two are actually two matrices. I can multiply them. And you can multiply by some other way also. That's there's some other way of like doing it. So using a function state way, and you can pass this matrix and you can multiply them. You can divide also, and yeah, compute inverse and all those kind of things. So this is about like NumPy, which will be useful when you will be performing mathematical operations. Right. So all the like data science and machine learning algorithms, they actually generate this data and represent them in some kind of like equations and then solve those equations. Like for example, gradient descent algorithms, and they require that you should have a matrix representation of those equations, and then you perform those matrix operations to compute the values of the parameters and to find the best set of parameters. So all these kind of linear algebraic operations are useful in machine learning and data science operations. Right. Here, this Panda, as I said, pandas are useful libraries where we can read files. So here I'm reading this. So I'm importing this pandas as PD. So this is alias. And then the PD dot. So anything like whatever alias I have given, dot the name of the function, and it takes some argument, and it makes the name of the file. Now, where is the file? So if I run here, obviously, where is the file? The file is not here. I mean, when I'm running, it is looking for this file. So file must be like at the same place, right? Same environment where this execution is taking place. So it is not there, but in pandas we can actually bring that file here. So I can. There are multiple ways of doing it. In the simple way, I can upload that. So let's see if I have that file. Or I have file. Okay, so I have file here. This.csv. So what I do is like let me. Yeah, it is there. So it is there. I can upload this file. Let's see where is the our Colab document, and then there is the iris file. I can simply drag and drop, and I'm moving this, and it gives me a message that uploaded file will get deleted when the runtime is recycled. Now the point is like when you log in into the system and you open this, say runtime is created for you, an environment, and when you come, like either come out from this, close this window, or after some time it itself will like log out to you from that Google Colab because you are unnecessary like occupying resources there. So that's a straightforward policy of users that if you're not using it, then the runtime will be disconnected. So when it is disconnected, when you reconnect again, so it will be from scratch. So what does it mean? That right now I have uploaded this file. Now it is in the same directory with where I have this in the same environment where execution environment where this code file is. So now if I run this, it will not complain. I mean, it will find it. So it has find it, given that it didn't give any error here. And if I display this data, this is the data, right? Data which is red, right? So basically it's a data frame. When you read the CSV file, which is, I can show you the CSV file also, and which is nothing but a kind of Excel looking format. This is Excel file itself. You can see like we have this data, which is iris data. Some of you might be familiar. It's a very popular data used in machine learning examples to demonstrate the effectiveness of some classifier. This database is used in machine learning application to show that how good your algorithm is, which work on this data. So basically, it's a data set, popular data set for machine learning classification problems, and even as well as clustering problem also. So here you can see like this data is stored as a tabular format with like which have like 5 columns. The first 4 columns are the attributes, sepal length. So these are like the data about flowers, iris flowers. There are typically 3 kind of iris variety. One is like versicolor, then sentosa, then one is Virginia. So 3 type of, so they are represented by this plant label. So 0 stands for one kind of label. And if we go down, then we may found that it's showing 10 entries per page. So that's why I cannot go. But if you go down, then so for some plant, you will have label as 1, and some plant you will have label as 2. In fact, absolutely there are 150 entries for each of these. Sorry, 150 total entries and 50 entries for each plant. So this is like data set containing 150 instances or 150 rows, 150 tuples, 150 instances. So whatever you call it, it's like a data set of 150 instances. A small data set, obviously. So what? Let me close this. So what we have done is like using this single command. I was able to read this file and get the data stored in the data frame. This is the data frame, and like you can see like this is a data frame type of data type. You can print the data type of this by the same command, which we have used multiple times earlier. And then we want to show the see the data. So just simply type the data, and you will see the structure of the data along with some data. So what it is showing the columns name, like 4 attributes, and the last attribute is the target attribute, which is like we also call as class attribute. And then each row is nothing but for one instance or one kind of flower. Now here first we have 0th kind of flower, one class of flower, this, and then last. So you can see like some of the entries here it is not showing, it's just showing as dash dash dash. So it suggests that obviously there are 150 entries starting from 0 index to 149. So the number of rows is 150 with 5 columns. So this is the size of your data, and this is the data frame there. So now this data is available for your program to manipulate. So you can now perform all kind of operation that there's like one simple function that you can do is like data describe. And you see there's what different kind of things that one single function can do for you. Here you can see that provides a statistics, right? So some kind of like data science operation. The data that describe just one function that you call, and it has described that total number of count for sepal length kitne hai, petal length, and so there is no missing values here in each of this column, and all are like 150 entries. Then what is the mean of sepal length, mean of all those data, the column are the standard deviation, the minimum, the 25 percentile, the 50 percentile. I mean, obviously, this describe has its code to compute all these data statistics and displaying it. But you see how simple is this idea? I mean, just using this function and you get such a useful information you can actually further access this information and can manipulate this data. This is information for your purpose. So whatever. Another function is data head function, which takes a number of values to show you how many tuples that you want to like to get displayed. So here, when you say 10, so 0 to like 9 tuples will be displayed. So you can, see any number of tuples. It will start from head. So that's first entry and so on and so forth. We want to see what are the columns. It's like just column. So it's nothing but a kind of the values of the columns that information will be displayed. What is the size of the data? It's like 150 rows and 5 columns. And if you want to show a selective, like you want to have like slices of this data, you can do it very straightforward way. Just name these columns, whatever columns you want to keep, and your table will be the result. Right now, it is not change the original data set. What it is provided a visualization of the or the slice of this data set. But then you can store this in some other data frame and can use it. Whatever purpose that you would like to. So this all like, and there are some other operations that you can access particular row. That is, for example, this I lock is like index location, like the second number. So indexing its second number is 0, 1, 2. So like actually, if you count from 1, it will be third entry, but then it's indexed as second, right? So accessing a particular row using some label, those kind of things are straightforward. Just like functions, you need to know. And similarly, you can see here, you can also like slice horizontally. You can see some of the rows, range of rows and all those kind of things, or a particular rows. Here we are giving a range. Just think about it. We're giving 3 numbers, 3 indexes, 3rd, 45th, and 6th, and that is going to display only. So just a way of accessing all that data that you would like to use, you would like to extract from there, want to perform some operations, remove from or add more column or whatever like you would like to do. So all those kind of things are. You can drop the column. So again, there's like this name of the column, which is like, and just a del command, and this will you can add columns and those kind of. So you see that you got the data. You can create data from yourself. You can get extract or fetch data from some other place, store it in a data frame, manipulate it in whatever way, and then these data will be ready to perform machine learning and sophisticated other data science operations. For plotting purpose, finally, again, there are useful functions in a library called matplotlib. So this is a like a library, matplotlib, which I'm importing. And this is another kind of statement where I'm importing this, right? So I have used import statement directly from import matplotlib as a matplot or whatever. I can give the name and MP or whatever. Or there's another way of importing. Here, when we use this from matplotlib, I'm using only 2 like module, pyplot and pl. Only one actually, pyplot, and I'm naming that or aliasing that as a plt. So I'm using only pyplot. There may be multiple modules, right? Which for different purpose, but I want to use only pyplot, so I don't want whole matplot to be imported, because as you import that, your runtime environment obviously has some limited resources. So all these are getting populated with this whatever you import. So efficient programming is like to import only those functions. People even go further, like and use only that particular function and get that function imported, and not all the whole module file is imported. So these kind of things makes your the code performance more efficient, and probably you can deal more complexity or complex problems can be addressed. So you should know. Here, I would like to have a plot, the kind of plot you can see. Like I want to. So we want to like plot over number of years how America GDP has varied, right? So you want to have like kind of scatter plot or in some sense like a line plot, right? So there's a function called PL plot, which takes this X and Y. So this like this is X and GDP is in Y, and then this color is blue. The marker is like those which will be indicating that what kind of so these markers may be required when you have multiple plot in the same plot, and the line style is dash dash. So you can see like you can actually configure this the way it may suit to you. And right now this like if I run this, you can see like it just one plot, but I can actually compare. I can show comparison of China GDP with America, which makes it more useful. And if I run this, then you can, sorry. So I have to, okay, so keep this as hash because that, sorry. This I don't need. So I need China and America GDP getting displayed, and you can see here I can. So this kind of visualization, and many times, right, when you do some kind of research or some kind of like write some document and you want to analyze the data, project that data, so visualization is very important, right? And in this section, we have included visualization. For example, here, let's say you have got a list of data and you want to find out like this or find the box plot. Many times we have multiple data for competing hypotheses and we want to like plot their box plot in the same figure. That can also be done. Here right now, like one set of data and I want to plot it. So it's very straightforward. I mean, we want to know about what is mean, what is the median of this data, right? And what is the standard deviation? What is the maximum, minimum? And there's like, so this mean median is all displayed here. If you don't want to display that and you want to simply the box plot, just one statement is like this plt dot box plot, which is like will this and which will get this data. What data? This NP array data, right? So you see this is a list. We converted in n-dimensional array, NP array. So that's NumPy. So this takes NumPy data. If you pass simple list, it will not give you the results that you're looking for. So you need to convert that into an NumPy array, and then you pass it, and then you are going to get this kind of. And if you want to have multiple box plots in the same figure, you can do that. And as I said, you have to add more data. So more like NumPy array data for all those box plots. And here you can yeah, add them in some kind of collection form, and it will show all those box plots. Some more. So I think this is not a difficult. If you play around, you know that it's like a PLT is the like package or the module that we have imported, and the plot is the function, and there are some other kind of plot. We have seen box plot, and there are more other kind of. So they require your data to be arranged in some format. See here, you can see that this is a list. So this just like this is list, right? So you've got your data arranged in the list format, and then those you pass these variables in this plot with this other configuration variable, if you wish, like blue line or marker, and what should be how it should look like. Sometimes if you don't pass this, they will take by default some color or some markers. That is also possible happen, but depend upon how you would like to get your figure displayed. So you see, this is really straightforward. I mean, once you go through this and do some experiment, and plotting any particular plot, visualizing your data in different way is right. Here you can see this is a bar plot. Right. So what this is like X data. So bar plot required for each X, right? What is the value of right? And this is your this X value, and this is your Y value. Y value means the value of at that point of so range is like 0 to, so it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. 0 to 9, 10 will not be included, as you know the range code, right? And for each of these X, right, we have got this randomly generated, and we are displaying this as a bar plot. So that Y part, which is nothing but denoted as X here, we might have used this Y here, the Y variable, but yes, and this range from the X variable. So X and this is Y. These two are plotted, and this is a bar plot, and we got this. So you can draw a histogram and other things in this in similar way. Like this is a scatter plot with one variable. You can scatter plot in between two variables, one on X and one on Y, and how this XY varies. So you can find out that with is there a correlation, and whether it's a positive or related, or there is no correlation. So the scatter plots are very useful. And again, some relationship plots which you would like to plot, you can show them. So this is how I'm stopping here. I hope that you understood the idea of like how do we perform this numerical computation, and how do we like collect the data, take data from the files. Generally, we store for data. I mean, a lot of time this data might be available as a Excel file or CSV or some other format which can be like also be accessed, and we can bring the data in our program memory and can manipulate the data. I can arrange it in format where it may be required by some machine learning algorithm or some data science algorithm, right? Or libraries, and then they will perform on those data and will provide us the kind of results. So this is how we do like data science stuff and machine learning stuff. I hope that that will be explained to you. But once you are comfortable of like accessing data, bringing data in your program, visualizing this data, then you can use the data to pass it to some other libraries here, like ML libraries or deep learning libraries, and they can do the computation. And they are just functions. Just you need to use them in some predetermined way, and then you can get the results, and you can visualize those results, and if you know how to plot those results. So that should give you an upper hand of like a good understanding of how you can perform like this data science operations, and how can actually you do projects on data science. So yes, I'm ending this. There is some questions. If I can, so instead of using Google Drive, how do I execute .py file? .py file by Google Colab from the computer directory. So what you do is like you create a new IPython notebook and copy all the code, right? So basically, what you can do is like you open a new notebook. If you can see that, so if and then this is the cell. This is no. So you can give a name here. Obviously, it will be not py file, but IPython notebook file, and you can copy all the code here in one cell, or you can add more cell. You can add more cell on more cell and can divide your code and organize in some very nice way and can troubleshoot and all those things. That's wonderful way of like handling your code or somebody else's code and you want to troubleshoot and sir, forward indexing in the list start from 0 while backward indexing start from -1. So obviously because 0 is one index, so we cannot say that when we use 0, so one has to be very clear that 0 start from where. So 0 start from left hand side, and we go as we go right, then it increases. So that's why I mean this has to be I mean -1. So the index cannot start from the right hand side. The index cannot start from 0. Otherwise, there will be confusion when you say 0. Then which 0 you are talking about, right? So it starts from -1. Yeah. Macro definitions in Python. I mean, macro is nothing but the function definitions that you can. So people use this. I mean, this create libraries. Basically module files, and there is a way of creating those files. I mean, they simply store Python functions, and we have seen what is a Python function. So that the definition, def, and the name of the function and argument and the body of this. So they put all these functions in one, relevant functions in one single large file with the .py extension, and then add some more files which to so that Python environment can understand that this is a module file. So I think that is beyond the scope of our course about this lecture. But yeah, you can create your own libraries and you can share those libraries with others. Absolutely fine. That's why this like Python has become so popular. And those kind of things is straightforward. People, anybody, any of you can create your own libraries and can share with other people. Okay, so thank you very much for your attention. I think you must have enjoyed this session.
Thank you so much, sir. Is the participant having any question?
They had some questions. I have given some answers now, but they probably also the time is getting up and they are thanking me.
Yes. Yes, sir. Thank you so much, sir, for such a nice lecture, nice and informative lecture. It was really a crash course on Python programming. You have covered all the topics in just 2 sessions. It was really fantastic, sir. Our participant has really benefited from your informative lecture. Thank you so much, sir, for being part of this faculty development program. Thank you so much, sir.
Hey, thank you. And somebody is asking that how to download Colab. So Colab is a basically cloud platform. It is not downloadable per se. I mean, it's provided by Google, but free of cost, so you don't have to download it. Only thing is, obviously, it requires internet connection. So that's the far side. I mean, you need to have a connection, then you can use it from your laptop or whatever. So thank you. I'm closing this session. Thank you very much.
Thank you so much, sir. All the participants, we will meet tomorrow at 10:30 a.m. for fourth session of this faculty development program. So, good day to all. Thank you.